too. Oh, it is recording already. Good. So, yeah. So we talked about pointers, and we mentioned how pointers are nothing but unsigned integers. The only difference the pointer has with a regular integer is that a pointer, when you are adding an integer, an unsigned integer, when you add 1 to it, 1 will be added to it. When you are adding 1 to a pointer, the size of the target will be added to it. So a pointer to a double plus 1 is that address plus 8. If it's an integer, it's the address plus 4, and so on and so forth. Then we talked about integers, the smallest integer being a character, how to make an integer unsigned. We talked about that. We talked about floating point precision, saying that the number of significant digits counting in floating point variables is essentially what makes the precision. And we said floats, if it's 7, ignoring leading and trailing zeros. For double, it was 15. And then we went to higher ones that goes up to more than 100. So there is no point to going through that. We talked about Boolean, saying Boolean is essentially an integer designed to handle truth and falsehood. Still, like C, anything positive, anything non-zero is true, 0 is false. But what Boolean type does is that any value you put in it, it takes the value of 1. And if it's 0, it's 0. That's Boolean. We talked about initialization, and we said from now on, just anything you want to initialize, put a curly bracket in front of it. Initialize, not setting. You cannot set something halfway through a program using the curly bracket, and initialization was essentially setting at the moment of creation. So whenever you want to set any type of object at the moment of creation to something, you use curly brackets and not assignment and stuff. Just curly brackets and put the values inside. Whatever the type is, just match that. If you have a structure that has 5 entities in it, put curly bracket, put the 5 entities comma separated with no assignment or nothing. I don't want to show the code to you. You remember what it was. And if you leave the curly brackets empty, essentially you are defaulting it to whatever value that is default is. A pointer being set with 2 empty curly brackets, null pointer, where an integer is 0, and a class, its default constructor. We talked about auto. We said auto essentially grabs the type of, so whenever we have no use case for it yet, but when you create, when you want to create an object, creating that object setting it, initializing to a value. If you do not want to write the name of the object, if you don't want to write the type of the object, it picks it up automatically from what it's being initialized. So when I say auto I is equal to 0, because this 0 is integer, it automatically picks up the integer, and the I becomes an integer. And that's where we stopped. So let's continue. And I'm going to bring it over here. Any questions on what we talked about last time? All right. So
we talked about initialization last time?
Yeah. Last initialization was the thing that we ended things with. So initialization was essentially this one. We talked about initialization like this, and we said this is the preferred way with braces, type safe universal form of initialization. And if you put empty brackets in front of it, you're essentially calling its default constructor. For an integer, it's a 0. For a double, it's a null pointer, and so on and so forth. Okay? right, so the next thing we need to talk about is type alignment, and something that I did not actually cover from the first week. I'm going to talk about it now. It is important, so I'm going to continue with that. That is real syntax of main. We need to understand what it is, okay? So when you are writing a main program like this, okay, life is good and everything's beautiful, right? But main's signature is not that actually. It has two different sides. It's overloaded. It has two different types of signatures that you can use. So let's go through it and see what it is. When you are writing a command line, so let's actually, I'm going to bring up over here, open folder and File Explorer. Oh. Open folder, File Explorer. I just want the path for it. Copy. Okay, now I'm going to open a command line. No, what was the prompt thingy for? Prompt $G, probably $G. That's what I want. Yeah, that's better. Okay, so and I'm gonna go to x64 because I'm doing a 64-bit thing. In here, I'm gonna go to debug. So this is the directory in which my executables are getting created for this program. So essentially, if I right now type over there, what is the thing? 04 September 15. So if I type that, 04-September 15th, if I type this, it's going to run the program that I have written. So this is where the executable is. Are we okay with this? Okay. And people at home, when I say, are you okay with this, please give me a thumb up or something that I know you're not asleep, so I can see that you're there. Okay? Oh, I have two Abhisheks. I didn't know that. Abhishek Sharma, okay. All right, thank you. And those are the only two who gave me the thumb up. Anyways, so have you ever thought, when you're writing a copy command, like for example, if I want to say that copy 04 exe to, I don't know, myprg.exe, what happens? CP over here is a command that you're calling, right? So it's essentially an executable that you're running. So how the devil it's receiving these two files as names? So it essentially receives the first file name and the second file name and copies the content of this one with that one. So that's so to have something like this, that's actually what the syntax of the main is for. So the main that you have over here, it receives two arguments. The first one is an integer, and it's customary to call it argc. Okay, and the second one is an array of pointers. We call it argv. You can name it anything you want, but if you do that, everyone's going to hate you because nobody, like this, since the beginning of time, we call the first one, I'll tell you what. So the second one is a character, argv, pointer array, something like that, okay? Oh, sorry. Character, pointer, argv, and I do like that. So, so when I say argc, essentially it means argument count. How many arguments are in the command line? The second one says argv, that's the vector in which, when I say vector, essentially means an array. Okay. Now, can anybody at home tell me what is the meaning of, so forget about the command line argument that you see over here. I have a question about C programming. When I say null terminated array of strings, what does it mean? Somebody at home. Null terminated array of characters. What does it mean? Or when we say string, what does it mean? Everybody's quiet, so I'll ask. Andre, Karkin, or Korkin. Okay. I don't know why people join online when they don't answer. Doesn't make sense to me. Can anybody hear me at home? Hello? One person? Okay, this is gonna change. Okay.
Please repeat the question.
I said, do you know what is a null terminated array of characters? What does it mean? When we say a C string, we call it null terminated array of characters. What does it mean?
That there are some characters back to back and they end with a null terminator byte.
Yes, and we do that because arrays in C language don't have length. We don't know what is the length of an array. You cannot know what is the length of an array. Thank you. That was Abhishek Sharma, right?
Yes.
Okay, you got 1% for your midterm. Remind me of it. Okay? You got 1% extra for your midterm. All right, and that's when you answer, I pay you credit. Okay. All right, so why we add null termination at the end of strings? It's because we don't know what is the length. So essentially, when you are having someone's name, we say put 50 characters over there, maximum length of a name that could be in the world. Whoever's name we are receiving, we put the characters inside. To show where everything ends, we put an impossible character at the end. An impossible character is null. It's something that doesn't mean anything in ASCII code, ASCII table. That marks the end. This null termination is not only for characters, it can be used for anything. Especially the second argument that we have over there. So the second argument that you see over there, argv, is an array of pointers. A null terminated array of pointers could it be, but they didn't do it. Instead of doing that, they put the number at the beginning. Okay? Well, I'm going to come to the null terminated pointers, so just I'll remind you later on what it is. For this one, you don't need to worry about that. But the second signature of main that I'm going to come, please remember what I told you about null termination. For here, when you say an array of pointer, it's an array of pointer to characters. And we know that array of pointer to characters is suitable for C strings. Therefore, this is essentially an array of C string, and the length is argc. What is argc? Is the number of things you see on the command line. So in the command line over here, I have CP, then I have this, then I have that, so argc will be 3. So if I actually write it like this, if I write 04 September 1, 2 tie your shoe, and then 3, 4 shut the door. So if I write something like this now, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 stuff at the command line. Do we understand this? Do we understand this, people at home? Yeah. Okay. Yeah, thank you. All right, so now I'm going to use that. So in here, I'm going to do this. I'm going to say I'm printing that. Then I'm going to say 4, 2. Actually, forget it. Integer I set to 0. And I less than argc and I plus plus. So essentially, I am going through a loop argc times. Then in here, I'm going to say C out I plus 1. So essentially, I'm showing a row number. And then I'm going to show C out. Oh, and I'm going to show argvi, and then I'm going to go to new line. So what happens over here, it first shows a number, then shows the string that is sitting that RVI. So RV0 will be the first argument, and so on and so forth. Now I'm going to compile this. I'm not going to run it. If I run this, you're going to just see 1 because it's running itself and there are no arguments. Nothing is passed to it. So if I just run it, you're going to see one thing is printed, and that's the name of the program. You see 1? So essentially, any time that you are running your Visual Studio, this is the command that is right, but it puts the full path and executes it. Okay? But now if I go back to the command line that I had, and I hit enter over here, this is what I'm going to see. So the first one is September 15th. So it doesn't matter what you have in here. If it's full, it's not intelligent to know where this thing is. Whatever is on the command line, it's going to just pass through. So as you see, I have 11 of them, and you can detect them. So this is how the command lines are written. All the commands are there. If you go home and write a copy command of your own. And you can actually have a syntax help for it too. If argc is not 3, because the command line needs 3, a name of the copy, source file, and destination file. If it's not 3, then you show a help file. If it is, then you get the first one, try to open the file. If it's not, you give it an error. So you can literally write anything you want, okay? This is what we have in the notes, but the next thing that I'm going to tell you, it's not in the notes. That is the third argument that you can get in the yes.
No, I'm sorry. What's the point of writing? I understand what you're saying, but what's the point of writing those variables within the main, the int main parentheses?
You're telling me what is the point of passing the values from the command line?
Yeah. What's the?
So if you wanted to write a copy command, how could you do it? You had to say, please. So you have to say copy, then show. Please enter the name of the source file. Please, and it will be an interactive thing. Command lines are not like that. You need to be able to pass data to an executable on the command line in one shot. That's the point of it. I don't know. For me, I learned this thing approximately, I don't even know when I was 18. 40 years ago, and I remember that day that how happy I was because now you can run your program in 10 different ways. You can give options to your command. The submitter command, how does it work?
Submitter command? I don't know.
The submitter, that you submit your files, your assignments with it.
Oh.
You write submit, you put this, you put that.
Right.
This is how it's written. I wrote it like this. So I essentially received the name, I received the name of the executable. I received the, like when you put -do, I'll take a look at the say if it's -do, I'll show you the due date. That's what it is. That's essentially what it is. Okay? So this is written to write commands. And without that, I couldn't write the submitter command. Right? And so this is the real syntax of main, so I'm going to call it over here a real syntax of main in notes. By the way, this is not C++. This is C. It has nothing to do with C++. Okay? Now the second one is adding the third thingy over here. Character pointer env. Now this one doesn't have a length. It doesn't receive a length. This is null terminated array of character pointers, which means I cannot check for the length, but what I can do is to write the exact same code in here and write env over here, but for the condition, I'm going to say envi. So essentially, I'm saying if it is not null, print it. when it reaches to, so I don't know how many there is. What is that EMV? All the environment variables in your system. You want to know how many CPUs you have on a machine? You want to know what is the name of the user logged in? You want to know what is the home directory? You want to know what is the path? Anything that is set in the operating system as an environment variable comes up on that one. So if I run this program now, this is what you're going to get. I have 62 different things. So let's start from the beginning. There you go. All user profile is program data. App data is in C, users var that, yada, yada, roaming. Common program files is in C program files, common files. I don't know. Derived data, deriver data is C, yada, yada, deriver data. Let me see. Home drive is C. Home path is this one. This is something that I always tell to my students. Operating system is Windows NT. Anybody's old enough to know what Windows NT is? You don't know what Windows. So there was MS-DOS, then Windows came, then it was Windows 3, and then 3.1, and then it was a Windows that was used only for with professionals, for networking stuff. They called it Windows NT. And it became the base structure for all the Windows to come. Therefore, the operating system is still Windows NT, which is from 20 years ago. So that's what the OS. So when you say Windows NT, it means all the Windows that come. Path, these are all the paths that you have, like the path that operating system searches. But one thing that you need to know is that number 21 is one string. If you want to know what the variable is and what the content of the variable is, you should search for equal sign and split it in two. What is at left of equal sign? That's the name of the variable. What is at the right side? What is the content of the variable? So that's that. Yeah, there you go. What is that? Like the processor architecture is the AMD 64, family, yada, yada, stepping. So you can see what is your CPU is. Anything you want. Anything you want is there. Okay? We good? So see over here, username is fardat.soliman. It means that's the person I'm using. Yeah, things like that. We good? Okay, so that's not in the notes, and it's very useful. I think you need to know. Okay. So this is B, real syntax of main. Yes.
You said this the RxC, V, and ENV, it only applies to C, you said, or?
No. It comes from C. There is nothing that applies only to C. C++ is a superset of C. Anything in C happens in C++, so it comes from C. Okay? So how do we debug these programs using an IDE? Like if I have a program that actually receives information from the command line, like how do I do F5 and it passes the stuff to it? Okay? In every IDE has its option in debugging. So if you have Xcode, go find it. But here, it's like this. So what you do, you go to the properties, and in the properties you have debugging. In that debugging, you can add the command line arguments. So in here I can say, here are the command line arguments. Okay? And I'll click on OK. So when I run this program now, Control F5, you will see here are the command line arguments. Okay? So if you want to pass stuff to your program for debugging, I think your assignment 1 needs that. By the way, your assignment 1 is up. Okay? So when you do that, so you can use that type of debugging. So let me actually, I should have made this better. So in here I'm going to say cout command line arguments. Okay. And here's cout. I'm going to say OS. By the way, this was on Windows. If you run the OS thingy on Linux, it's a completely different ballgame. So what you see is what environment variables on Linux are. It has nothing to do with the C language. It literally extracts the operating system stuff. OS. Okay, let me run it, Control F5. I just want to make sure that it actually shows that. So, command lines and yeah. And I'm gonna put an NL over here because it's so many things that it becomes confusing. Okay, so Control A, Control C, copy, and I'm gonna go back in here and paste it over here. Yeah, I just wanted to make sure that it shows it properly. Yeah, that's better. Okay. All right. Questions down to this point? Okay, now we're going to talk about alignment. Now we're going to go back to this was from week 1, I forgot to mention. Now it's covered. Oh, another thing that I have to tell you, many times I don't have time to go through all the details. So you're responsible to actually read, and if there is anything missing, you either understand it yourself or you come and ask me the next day. Many things are not going to get covered. I'll try to do it as the best ability that I have. Let's put it that way. Okay, so let's go back over here. Type alignment. So how do I explain this? Usually I do it very visually, but people at home, let me think about it for a second. Okay. Computer operating system has a very weird way to try and find variables in memory. You could think about it as if to find the address of anything, it has to start from the beginning of the memory and go count and get it. So it means if you have a variable at address 20 and you have another variable at address 24, if you want to grab the one that is at address 20, it starts from the beginning, counts and reaches to 20, then it gives you the value. When you want to get the 24, it won't go to 24. It has to go back again from 0, count to go to address 24. But it's so fast that it's almost instantaneous. Are we good? To ease this and make it faster, it goes by the step of the size of the thing that you want, which means if you want a character at address 20, it loops 20 times until it hits it, because a character is one character. But if you want to go get an integer at address 20, it goes 4 by 4. So it goes 0, 4, 8, 12, 16, 20, stops. Got it? That's how it works. Don't look at it. That's how it works. This is how it does it. Because of this fact, all entities must sit at the address that is divisible by their size. You cannot have an integer sitting at address 5 because it's not divisible by 4. Okay? And that makes things extremely weird. Let me explain. Give me a second.
You said this was with Windows?
No.
This was every
No, it's universal in all computers. me a second. Give me a second. Give me a second. Okay, I'll do something else. So, take a look at this. I'm going to write something like this. I'm going to write struct rec, okay? And in here, I'm going to create double A and double B. All right? So, what is the size of a record in memory? Size of the record in memory is 8. No, it's not 8. A double is 8.
Oh yeah, 16.
16, right? How do we know if it's 16? This is what I'm going to do. C out, I'm going to go C out. Size of rec. So size of essentially tells you what the size of something is in memory. We okay with this? So now, and sometimes people read this and they use this instead of string length by mistake. Size of gives you the size of something that occupies in memory. That's what it does. So if I run this, you will see that it's going to say 16. Oh, and I have to. It's still showing the arguments? Why is it doing that? Wait. There we go. 16, right? So. Now I'm going to create another one. I'm going to say struct record character A and double B. Okay? Record 2. Record 2, let's call that one record 1. So what is the size for record 2? I have a character and double.
2, or
It's going to be 9, right? All right. So let's show that one. So in here, I'm going to do it like this. That's rec 2. And so I'm going to say over here, rec 1. Just for us to see. And this is rec 2. And let's run it. Oops. It's 16. Why? Now you're the computer. Imagine you want to put the rec as a structure in memory, and you are at address 0. When you are at address 0, character A will be sitting at address 0, right? So next available address is 1. Double can't sit at 1. It has to keep going until it reaches to an address that is a match to its size. So your character is essentially sitting at address 0, and the system says 1 can't do, 2 can't do, 3 can't do, 4 can't do, 5 can't do, 7 can't, 8, okay, now I can put the double over here. So essentially you're wasting 7 bytes between the two. To prove it to you, I'm going to do this. Middle. Still 16. Doesn't make any difference because you're going to have a gap in the middle. Okay? Now, the best, so I'm not going to go through the details to tell you how things are supposed to be done in too much detail, let's put it that way. But I'm just going to mention it to you like this. Whenever you are creating a structure, make sure you sort it in a descending order. Put the biggest one at the beginning and then go smaller. That makes your structure the least size possible. It reduces the number of things. That's number one. Number two, Rec 1, structure 1, Rec 1. Okay, it has two doubles in it, right? What address Rec 1 can sit in?
Sorry, could you repeat that?
Okay, we said that a double has to sit at the address that is divisible by its size. Now I want to say Rec 1. If I want to put Rec 1 is not just one double, it's two doubles, right? If I want to put Rec 1 someplace in memory, what should it be coefficient of, 16 or 8?
Oh,
8, because it has two doubles. No matter how you put it, if you put it at address 8, they both are going to sit at the proper thing. But sometimes you can do a structure in a way that when you set it up, it has to sit at 16. So the alignment of an entity in memory is different with its size. Rec is 16 bytes, but it can sit at any address that is divisible by 8. So the size of Rec 1 is 16, but its alignment is 8. Do we understand this? That's size of an alignment. That's it. Okay, so now I can actually check the alignment for it. So I can actually do like this. I think the other one is 8 too. Yeah.
Can we call it its type alignment or memory?
Yeah, type alignment. So there is one rule. Alignment and size of a fundamental type is always the same. So if you have an integer, its alignment and its size is the same. Okay? I think. I never tried it, but it just makes sense to me because you cannot break it down into smaller pieces. But you have a compound type, I'm not even begin to think how you can align it. So that's why we have align and we have size of. So when you actually say align, was it alignment? Give me a second.
Yeah.
So align of and align of. Okay, so in here I'm going to say align. Control F5. So as you see, the alignment of both is 8, which means you put Rec 1 and Rec 2 anywhere in memory, it has to be the address must be divisible by 8. Okay? And size of. You can reset something to align in a different way, depending on how you're. So now when I actually, I'm telling you this, you need to know that if for any low-level reasons you want that thing to align as 16, you can say aligns 16. Actually, you have to put it before the name, not here. align as, control, align as 16. So now if I go rec 3 now, so let's make this 3 and 3 and the reason that I don't bring, I have a code ready over here that I can copy and paste. The reason that for concepts that are new and a little difficult to grasp, I type it to slow myself down and force you to think about it, okay? I can bring the code, I'm ready, but sometimes it's better to do it like this. It slows me down and gives you time to think. So now if I run this, oh, this is the previous one, sorry. Copy. Change the wrong file. Save, and let me bring it over here. Control A, Control V. Okay, Control F5. So now if you look at it, now record 3 would align as 16. Okay? They're all 16, but now it forces that to go in segments of 16. Okay? All right. So in here I'm going to say align as CD, align as .cpp. We talked about pointers in full, so we know what they are. I just want to... Did we talk about generic pointers in this class? Generic void pointers we didn't talk about, did we? Okay, so void pointers are essentially, so we cannot have, we talked about void. We said void is whatchamacallit, void is when you have no type, no type, you write void. So, but you cannot create a void variable because it doesn't make sense. But you can create a void pointer. What is a void pointer? A void pointer is to have a pointer that doesn't associate itself with any type, which means target of will not work on it. A void pointer is pure address. So you cannot say void pointer, if I say over here CI target of V and I try to print it, it's going to tell me I have no idea what's setting over there. It's just a pure address. That is used whenever you want to receive address of anything and you don't want them to cast it. See, you can put the address of an integer in a void with no casting. But if you have a void and you want to put an integer, you have to cast it. So anytime you want to write a function that wants to receive the address of anything, and then you want to do something with it, that's void pointer. Void pointer is a general pointer, and pointer arithmetic doesn't work with void. You cannot say V++. You cannot add to the address of void because it doesn't know what is the target to add it. So pointer arithmetic doesn't work for it. Yeah, so this is void pointer.cpp. Now, as an example on what it is used for, let me show you this. For example, I want to get a hex dump of memory. I want to see what's inside memory regardless of what type of an object I have. Okay? So now I can have an integer set it like that, double set it like this, So what is the proper variable to receive the address in? Hex dump, it means I want to break it down into smallest pieces, into bytes, and print the content of a byte. To do that, I create hex dump, void pointer A, then I cast that void pointer to a character. Now I have an unsigned integer, small unsigned integer. I can one by one print that as a hex dump and see what's going to get printed. And I'm going to say set the output as hex. So this is a manipulator. When you write hex, it prints it in hexadecimal. Okay? So now if I run this program, it essentially shows me what is the content of I and X in bytes. So this would be it. Build errors, why? Return value does not match the... Oh.
Sir, you coded hex dump, right?
Pardon me?
Did you code hex dump? This is your piece of code, or is this built in? Hex dump?
No, hex is built in. It's a manipulator.
Okay, so you're showing what it's doing.
Yeah. It's like you write fixed, or you write, I don't know, left, or you write right. So hex does that. There you go. So that integer that you see over here, 2345, this is the bit pattern in it, in memory. That double that you have, 4.56, this is the bit pattern in memory. This is how it's distributed. Now, you can actually write that thing in bitwise. Keep dividing it by 2 and show it in bitwise. But we don't have any bit. Hex we have, which we cannot show in bit. When we go further as a practice or a challenge, I'm going to tell you, write a manipulator called bit. So whenever you do that, from now on, everything that is printed is actually pattern. So you can actually write that yourself later on. And now I'm going back to decimal over here, as you see. Okay? Okay, so that's that. We know about references. I'm not going to go through it. You know exactly what they are. So let me just write this over here. I'm going to say C, really? C, D, E. F void ptr in use dot cpp, or I could have called it hex dump. Okay. We know about references. There is nothing to go through. So reference is essentially a new name given to an already existing variable. We know that from OOP345, right? All right. But now we need to understand a concept called, so in here I'm going to say ref.cpp. We need to understand what is an L value and an R value. We're going to go later on deeper in this concept, but understanding what L value and R value is. L value, essentially, think about it as left value. Anything that you can put at left side of an assignment. Okay? R value is something that can be at right side of an assignment. So any L value could be an R value, right? But any R value cannot be an L value. You can say A is equal to 20, but you cannot say 20 is equal to A. You cannot say 20 is set to A. You can't do that, right? So anything in the assignment. So that's that one. Now, we have what we learned in OOP345 is an L value reference. L value reference is a reference that can sit at left side of an assignment. We actually have an R value reference. What is an R value reference? R value reference is a reference of anything that is an R value or is a temporary thing. So, for example, if you have, let's put it this way. So, I'm going to show you the example. I'm going to add to it, okay? So, you have seen an L value. I showed it to you. Now, I'm going to show you an R value. So, if you put 2 ampersands, it means N will be an R value reference. Now, take a look. The first print, as you write X over here, will pick up the first one that is a constant int, yada, yada. You see that? because that's an L value and X is an L value. But 20 is an R value. Because it's an R value, it knows it has to go to the next one. Okay? So you can actually detect. So what I can do even is this. So what is another type of R value? I can say print over here. I can say int X. What am I doing here? Think of it, because it's an object-oriented language, think of int as a class. If I have a class, and this is casting, right? So essentially that becomes a temporary nameless object that is built out of X. So it is a temporary object. Because it's a temporary object, it's considered as L value. Therefore, it's got to be picked up. So if I run this program, and this is an R value too. So if you run it, it can actually detect what you have. Now, one of the biggest problems in computer science is that at many times when you are passing around temporary values, by mistake, we copy them. I'll explain exactly what it means. In OOP345, this is how we worked our way around. Where is it? So I'm going to stop sharing the screen, and instead I'm going to... There we go. That's me. So... So this is me over here. Oh, the other way. All right. So could you please come over here with your cup? Stand beside me over here. It's going to see how many of us have. So what happens over here is like this. I am function coffee that returns coffee. This coffee mug of mine, okay, is in my scope. Therefore, I cannot pass it to him. So what it has to do to receive coffee from me, he has to bring his cup to me. In reality, what it has, he has an empty cup. I empty my coffee into his, and he receives the cup. I have an empty cup. That's reality. But this is not how we program. When we are programming, when I want to return the cup to him, what it does, he calls a copy constructor. Because this is a temporary, this is an object that cannot be returned by value, automatically it's going to be copied. So what happens, instead of actually pouring this coffee over there, what it does, it builds a brand new coffee out of this, pours that one in here, and I throw away a full cup coffee, and a temporary coffee is thrown away too. Do we understand this? So any kind of return value that passes along gets translated into temporary nameless object. The temporary nameless object is handed to him. He receives that, get that imaginary thing, empties it to that one, throws that one away, I throw this one away. So two objects with full data are thrown away, and the third one he's using. That's how we do it. Are we okay with this? Okay, thank you. Now, with this feature that we have in here, I can create a new constructor that receives an R value, which is essentially telling, hey, if what is being copied is a temporary object, do not do copy. I can take over. And what I can write is what we call a move constructor. So instead of a copy constructor, I write a move constructor, which essentially means if I want to pass a coffee along, what I would do is simply say, okay, this is the object that is coming to me is a temporary one. Why do I copy it? All I need to do is to make my pointer point to its data and make its data null and throw it away. So essentially, he just pours his data to me. He has an empty cup and throws it away. We'll see how it's done. It's called a move constructor. Or if I'm assigning a temporary thing to another, instead of having a reference pass and copy everything in assignment, I can move this stuff around, which is called a move assignment. Therefore, we have rule of 5 now, not rule of 3. Rule of 5, copy constructor, copy assignment, move constructor, move assignment, and destructor. Therefore, C++ automatically or manually will move stuff around instead of copying it. Therefore, it's hundreds of times faster. Imagine that you have a function that receives the temperature of sensors in the oceans in past 10 years. That's millions of numbers. And receives it and puts it in a packet and returns it to another program. If that thing's going to get copied, it takes, you know how slow your program's going to be? But when you do a move, you just assume it and you'll see. When we come to it, you'll see what it is. So that's where we're going to end up soon. This is kind of a introduction to that. I have problem with alphabet. G, not F, E, F, G. Okay, so this one's going to be H, R value, and the CPP, and I made a mistake over there. Sorry. C, so this is G, this is F, okay, which brings us to how we can actually manually force something to be moved. Yes?
Could you quickly repeat the rule of 5 again? The constructor
We have a lecture on it.
Okay.
A separate thing only for that. Don't worry about it. Okay, so yeah, it was just an introduction. Okay. So now take a look at this. You see that? So now I can actually force to treat a regular variable as move. So if you have a regular thing, a regular object, and you don't need it, instead of copy, you can manually move it. And that's std move. So when you say move, it literally moves it. So it actually passes it to a... So don't forget, an R value reference is still a reference. It's a new name for an already existing thing. The only thing it does, it detects it for you. It's your responsibility to do the actual move. In this, it doesn't make sense, but when we write a class, you'll see that it makes the whole lot of sense. Okay? So essentially, with two references, you can either detect if something is literal, temporary, or about to die. You can detect it. And then through that detection, you can take the proper action. And then you can sometimes force something to be moved if you want to. Force to move using R value. R value reference, essentially. We talked about arrays. We know what all the good things about arrays are. Arrays are getting initialized exactly the same way that universal type of initialization is working. So it's the exact same thing. Oh, sorry. Don't look at that again. Too early. I didn't talk about range-based loop, did I? Range-based loop. I did not. Okay. So first, let's talk about arrays. So we have aggregate initialization. We don't need this. You don't need to do that. Right? This is the usual loop that we used to do, right? So we essentially says integer I is equal to 0, yada, 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 yada. Instead of doing an index, now what we have in C++ is called a range-based loop. What it means is that you check and to see what the element of the array is. Then you're going to say, hey, this is the type of, this is a variable for the element. Assign this variable one by one to everything and loop through it. So instead of actually writing something like this loop I can write for int. So what I can write is essentially int I, oh, come on, int I, a. It means go through the I. Oh, actually, let me change that I's name to something that makes more sense. Element. Okay? So go through the I, set the element to every element one by one and loop through it. So the first time the loop is happening, ELM will be the first, the second, third, fourth, and fifth, and goes through it. This is called a range-based loop. And it works with built-in arrays only in the same scope. If you pass this array as a function, in a function as an argument to the other one, it loses, as what we call it, in its arrayness. It's not an array anymore, it's a pure pointer. Therefore, the compiler doesn't know it's an array. No range-based works on it. So range-based loops only work with built-in type in the same scope. Soon we'll see we have so many STLs, standard template library for arrays, that it works in all of them. So they kind of backward engineered it so it works on regular arrays too, only in the same scope. So this only works in the same scope of the array. Okay? And essentially, it becomes a range-based loop. Okay? So it tells you 1, 2, 3, 4, 5. We good with this? All right. Now, having said that, the aggregate initialization, just put an emphasis on it, works as such. So you can not mention the size and put the thing. It sets the size automatically. If the size is shorter, everything else becomes default, not 0. So if this is an object, the rest becomes default, whatever it is. And following that fact in line 7, same thing in line 8. If you don't put anything, everything else is 0, therefore everything becomes 0. So that's that one. So all elements 0, rest 0 initialized, and that's the range-based loop for every single one of them. Yes?
I thought in line 8, if you didn't assign anything, or in line 7 you did, it turns into null or no?
What is null?
Null is an empty character or empty space? Well,
My dear, null essentially means 0.
okay.
Null is a piece of memory which all the bits are set to 0,
Right.
which it is.
0.
Or if it was an object, it's a default constructor that would be called.
And if I print C right now, in C, that will be 0, 0.
Yeah, you'll see. So I'll run it. It's right here.
Okay.
And the same thing for the first one. So first one, as you see, The very first one, as you see, is only 3 because I don't have a size. It matches the size. The second one, it sets the size, sets the 3, and the rest becomes 0. And the first one, everything is 0. We good? So this one is, so this range-based loop that you saw over here, E actually becomes, because you do it like this, the E over here becomes a copy of each element, which means is if inside the loop you change E, the array won't change. Okay? If you want to actually deal with the array elements in a range-based loop, you have to kind of play a trick. Let me just put this thing in. K, this one was, so initializers, yes. Array init.cpp. Okay, so in a range-based loop, if you want to change the values inside, then you need to pass a reference. So now I can actually do something like this. So the first one adds 10 to each element, and the second one just prints it. Okay? It is always better to use a reference. These are primitive types. It doesn't matter. But if the array that you're going are employees in a company, then believe me, this is going to take much longer than that one. And if you don't want to change it in a loop, just make it a constant integer reference. It doesn't matter. Or constant employee reference. With this one, every single time a copy of employee is going to happen. Careful. Okay? So now this range-based loop will actually add 10 to each. If you did it in the other one, it won't add it. Because this one is a reference, you can actually manipulate the array using the range-based loop. So range-based loop in arrays using reference. Yes, sir.
You said with, oh sorry, with the
Coming up, yeah.
From line 10 onwards, does it slow down, you said, because it's copying, or what?
Yeah,
It's
literally.
Yeah, because when it's...
Over here, you're just using the elements. Over here, every single loop, you're copying the elements, first element, into an integer. You run it, and then you copy again, then you copy again, then you copy again.
So why can we use the reference in the cout and in the print?
Always. Like, this is bad practice. If I wanted to do that, I would have done this, actually.
That speeds it up.
That speeds it up. Yeah, especially with this, it's not that much.
Right.
Yeah, because the bottleneck is cout, not the copy. But if that was, like, say, transcript, you're having a transcript with 90 different things in it and a student name and all the stuff, and you want to do print one by one, then this would be much faster than that. Okay? Okay. Yeah. So, you remember that we don't give you a break. I know you're all asleep, but we don't give you a break. We'll go till 35 and then we leave 5 minutes before, so I can catch up with the other class. And the other class starts 10 minutes late. Okay, that's how we kind of manage the class. My apologies. I have 2 classes back to back. I have to do this. So let's talk about classes. So essentially, classes are groups of data members and member functions, and using encapsulation, you make things private. We're good with this? Okay. So now, with respect to constructors and initializers, we know that each class, these are all kind of reminders of what we have in OOP345, right? So you can actually initialize something over here. You can initialize something over there. You can, you can, when I say here and there, people at home doesn't see it. So you can initialize like number 7 and 8, and then you can initialize in a constructor. It's in what I call initialization area, which is essentially after the constructor with the comma before the body of the constructor, or like that. These are all initializers. But remember, the sequence of the action is always from top to bottom. So if you do that, the other one is going to overwrite it. You usually don't do them both, okay? So in this case, if the item is defaulted, these are the value. If not, these are the value, okay? So first, second, and third is the body. In body, you cannot initialize. In body, you can set. When you reach to the body of the constructor, the properties of the class are already initialized. So yeah, just please remember that. You cannot initialize any members here. It is too late, and they are already created. Okay? Remember this. This is extremely important. Are we good? Yes.
Just trying to clarify.
And by the way, now you see this, not that. These are both correct. So you try to use this from now on. Because it's initialization, you can use curly bracket. Yes, go ahead.
Just to clarify, initialize only members here. That means we can't.
What? Give me line number, not.
Line number 13, the comment.
Okay.
It's too late. They're already created, meaning we cannot add more member variables or create more.
No, what I mean is that. If I have something like this, volume is already created with garbage in it. It does, you can overwrite it, you cannot initialize it. Initialization only happens either up there or in the initialization area between the constructor name and the. After that, you miss your chance, it's done. So if you have another class in here that doesn't have a default constructor, your code won't compile because it tries to default it. Yes. Oh, okay, you just scratching? Yeah. Okay, so that's that. Oh, shoot. Again, put the last thing at PP. So forget about that. It's pp.cpp, that's cpp. Okay. Control A. Copy. Actually, let me save it. Save. I'll change the name later on. Okay, so that's that. Now get ready for this. Get ready for this. Give me a second. Just a second. Okay. So let's say I have a class called name. Okay? So this name of mine has a first name and a last name. Okay? Now, by the, and I have a function over here, and these are all from OOP345, by the way, okay? So I have a set function over here that essentially sets the first name and last name. First, it deletes whatever it has, and copies and everything, so on and so forth. Are we okay with this? This is standard set that we had in OOP345. We good? All right. Now, to apply rule of 3, what I need to have, obviously I'm going to create a constructor for this. There's no question about it. So I will have a constructor that simply calls the set function. Absolutely no problem, right? Then I have a destructor that deletes the both. So that's the first thing of the rule of 3. Then I have a copy constructor that literally receives another one and copies everything, right? And then I have a copy assignment that simply copies the information from the other one. So essentially, same thing as a copy constructor, but in an assignment thing. But obviously, the assignment that I have over here, yes, because my set deletes everything that I have, so everything is good. Are we good with this? Very simple and straightforward, right? My question is, so let's close this one. And let's add a display too. With good old insertion overload. Again, these are all OOP345. That's why I'm not spending time on them. We good? What if I, let me just, give me a second. Okay, So,
Pastor,
yes.
is this set use like a allo copy?
Which one? Oh, you were out when we were doing this.
Yeah, sorry.
Yeah, so essentially it deletes first and second if the first and we good?
It's string copy, yeah.
It just, yeah, it's like auto copy.
Yeah, you made it.
Yeah, oh, so I'm just reusing the code. Okay, so let's say I have over here a function called make name. That is creating a name and returning it by value. Okay, this make name could receive something from string, from a console, like you're a get name, something like that, right? And then in main, and then another one, something like this. Perfectly valid stuff, right? This one is making a name, return, this one is printing a name. Are we okay with this? All right. So I can write now int main I can create a name, right? I can display the name, right? And I can receive a name, and display it, right? Now, when you're looking at this make name, so this one is going to be a copy constructor, we know that from. But this make name, when it's actually creating the name and returning it out, is the exact same thing that I was talking about, coffee thingy. Okay? So I can fix these things. How? Take a look. When I am actually doing a constructor, copy constructor, you see the copy constructor, remember this? In this copy constructor, instead of a copy constructor, instead of a copy constructor, I can do this. I can actually write over here name in here. I'm going to say name R value reference other. So this is exactly like a copy constructor, same signature. The difference, first of all, this will detect if what is coming is a temporary object, and it is a writable, it's not a read-only reference. I can actually modify the other. In this one, you can't. A copy constructor's job is to copy. You're not supposed to modify. This one can modify the other. Now, what I will do over here, in here, I'm going to say, hey, I'm going to assume it's data. Instead of copying, I'm going to say m first is set to other.m first. No allocation, no copying. My pointer will point to others data. And the same thing over here. I'm going to say m last is set to other.m last. Okay? Now that I have actually pointed to the other object's data, I need to make the other one not to point to it anymore. So now what I can do, I can say other dot m first is null PTR, and other dot m last is null PTR. Done.
This is moving.
This is a move constructor. So what happens is that no copying, no allocation, nothing. I just assume the data of the other object and free the other object. So the other object becomes empty. And the exact same thing I can do for the move assignment. So, oh, by the way, there is one thing that we need to do over here. And just don't ask me what is this. Write no exception in here. Why? Because the sky is high. Okay? when we teach you exceptions, you'll know what is that thing for. But you have to write no exception over here. Okay? Yes?
Doesn't this violate encapsulation?
No.
Because like the move constructor
Is changing the other one.
constructing a new object, right?
Yes.
And then it's pointing to the
Data of the other one.
that's about to die.
And yes. And it says now that you're dying, I'm going to get all your stuff. Why you need them?
But that's like violating encapsulation.
I'll tell you why it's not violating. Because you're thinking like a human being, not like an object-oriented design. Two human beings are two separate entities. That's what you're thinking. You're getting his belongings. In an object-oriented world, a class is allowed to access the private property of its own objects.
But
So you are two objects of the same type. It's not two different ones.
yeah.
You have one coffee and the other one is coffee too. So it can access the private property of the other one. No problem. That's not violating encapsulation.
Yeah, but like that's like
Again, other here is a name. It's not another class.
I know.
If you access another class, it's violating encapsulation.
Yeah, but this is assigning, right? It's assigning different
Encapsulation is packing the data and behavior of the same class together, not of two different classes.
Yeah, I know. But that's accessing, right? You like if you're in name class, you can access the private properties of another name class.
Yes.
Right?
Yes.
But can you assign?
Yes. Why can't you?
But it feels weird though.
It's yeah, because you've never done it. But after doing this, your program's going to speed up tenfold. Tenfold? More than that. You'll see what I mean. So we have the exact same thing for the move assignment. So for move assignment, we have that. So everything is exactly the same way like the other one. The only difference is that you've said, if I'm not, so you do self-assignment, to make sure it's not self-assigned. Then you say, delete my data first because you don't want it. So and then you get the other guy's data, you set it to null, and you turn this. Done. And that makes things hundreds and hundreds of times faster. Build errors. I have to add that thing. What is that? Secure node schmiglivingi. Control C. So what happens now when it comes to this point? When it wants to, so it goes inside, it makes the name, that's fine, let's make the name. But when it returns that one, instead of going to a copy constructor, it directly goes to the move constructor. And what you have over here is essentially, you say, why didn't it go in there? I do not know. I'll set it up and I'll show it. But I wanted to walk through it, but it's too late and we have to go around. so that's essentially it. There's nothing else over here is happening. So that's moving. And remember, the last thing we talked about was moving. I'm gonna post the code, and we'll start with this again the next time you're coming in during your lab. Okay? And you're gonna have a quiz next week. So this week. So I'll tell you what the questions are 2 days before the quiz. Okay? Pardon me?
When's the quiz? Is this week Friday?
I think so. Anyways, you have an announcement about a quiz today. Please check it out. Okay. All right. Have a good day, everyone. Any questions at home, people? Question at home? Anyone? Okay. All right. Okay, have yourself a beautiful day, and we'll talk later.